Assalamu alaikum everyone. This is my demonstration of complex engineering problem of EEE 4705 microcontroller based system design. Today I am demonstrating a classic tic-tac-toe game design using 8089C52 microcontroller. This project integrates hardware interfacing with complex game logic featuring both player versus player and a player versus AI mode. Our system uses a 4x4 keypad for input, an LM016L LCD for the display, and a custom assembly code to handle the game state. Let's look at the hardware configuration first. At the heart of our project is 8089C52. Note the crystal oscillator X1 providing the clock frequency and the reset circuit on pin 9. For the display interface, we are using port 1 for the 8-bit data bus D0 to D7 and port 0 P0.0, 0.1 and 0.2 for control logics, register select, read, write and enable pins. The input system uses a matrix keyboard. The rows are connected to port 3, 3.0 to 3.2 and the columns are connected to port 2, 2.0 to 2.3. Let's look at the assembly code. Writing this in assembly required careful memory management. We have defined the board as a 9-byte block in RAM starting at address 30H. 30H. One of the most critical parts is the check end routine. Let's find the check end routine. Okay. It systematically checks all 8 possible winning combinations, rows, columns, and diagonals after every move. If no winner is found and the move count reaches 9, it declares a draw. For the AI mode, we implemented a basic minimax light logic in the find base routine. The AI first checks if it can win in the next move. If not, it checks if it needs to block the player from winning. If neither, it follows a priority list, center first, then corners, then sides. Now, let's run the simulation. Upon startup, the LCD shows a welcome message. I am now prompted to select a mode using the keypad. I will press 1 for PvP mode or player versus player mode. Notice how the LCD updates. Since the LCD is only 2 lines, I have implemented a scrolling feature by pressing F. The display shifts to show the bottom half of the board, and pressing E shifts it back to the top. Now let's demonstrate something. I am pressing 1 here. Then if I again press 1 here, the code triggers the message taken routine from the assembly code warning the player to retry. Now if I press 7 here, see, I cannot see the move. But if I want to see it, I have to scroll down using the F button. Now I can see the move. And if I want to scroll back up, I will press E. Now let us switch to, let's restart and switch to AI mode. I'm pressing 2 for selecting the versus AI mode. Now watch the AI move, it responds instantly. I will try to set up a trap and you will see the AI block my move. Now I'm gonna purposefully loop to the AI to show you that the logic of AI, how the AI works. So here you can see the AI goes through the find best routine and finds the best possible move to win the match. Okay, the biggest challenge in this project was the keyboard debouncing. Let me switch to the assembly code again and go to the KP scan routine. In the KP scan routine, we had to include small delays to ensure a single button press wasn't registered a multiple times. In conclusion, this project demonstrated how an 8-bit microcontroller can handle real-time user interaction and decision-making logic. The setup could easily be expanded to include sound effects via buzzer or even a score tracking system stored in ROM. Thank you for watching this demonstration.